Hi, hello. How are you, my friends and students? So we are getting learning new things every day. So I hope so that you're happy means you are doing the work with the online sessions and whatever your teachers are saying, you're just following. So we have been discussing carbon compounds chapter. Is it not? This chapter is very important. Why? Because so many compounds are there, all are made with carbon. Today, Today, what the topics we are going to see is electrons of carbon, and second, we are going to discuss versatile nature of carbon, and third, organic chemistry, a small part, why the name has come. These three topics we are going to see. So let me ask you one question. What is the precious thing in jewelry? Precious. When you look at, you will feel, like that. Diamond. Is it not? Diamond. And did you see your pencil lead? Pencil, while writing the pencil lead, black in color. This diamond and this graphite, both are made of carbon. The diamond is also made of carbon. The graphite is also made of carbon. The same element having different physical properties but similar chemical properties are there. This particular phenomenon we will call it as allotropy. What does allotropy states that? Say one element having the different physical properties of element, properties in different forms with different physical properties having the same chemical properties, that phenomenon we call it as allotropy. So now we have seen two allotropic forms of carbon. What are those? Diamond and carbon. Why they have the physical properties are different? Yes, their bond structures are different. Bonding between the atoms is different. So in diamond you will see the different bonding between the carbons. In graphite you will see the different forms of carbon. Different bonding. In diamond carbons will be arranged in tetrahedral arrangement. How one carbon combines with four other carbons with single bonds. Each carbon in diamond, you will see that this carbon is combined with four carbons and forms a tetrahedral structure. And it gives a rigid structure and which makes the diamond very strong. And no free electrons are present. That's why the diamond is bad conductor of heat and electricity. Most of the diamonds occurs naturally, but even in lab also, do you know, we can synthesize the diamonds. Yes, under high temperature and pressure, you can prepare the diamonds, but problem is those diamonds are very small sizes. But there will be no difference, even though this diamond, how it looks, natural diamond also looks like the same. Now whereas comes to the carbon, graphite. Here what is this bonding structure? Each carbon combines with three carbons only with an hexagonal arrays and three carbons. But carbon has four electrons, no? One of the carbon will form the double bond among these three. One carbon will form double bond with another carbon and other two carbons forms the single bond. So what we have learned? Each carbon can bond with three carbons and forms hexagonal arrays and forms a layer by layer. In graphite you can see layer by layer. That's why here these layers are slide over each other. They're slippery, they're smooth. That's why the graphites are used as lubricants also. And you can see that here the bonding structure is unsaturated and availability of electrons will be more. That's why the graphite is good conductor of heat and electricity. So because of structural difference, we have the precious diamond on one side, graphite on another side. But both are carbon. But recently the scientists have discovered another form of carbon, amid the geodesic structures molecules. With more than 60 carbon atoms forms a single molecule. C60, 60 carbon atoms forms a football-shaped structure with 12 pentagon rings and 20 hexagon rings, exactly like football shape. And the name of that C60 is called Buckminster fullerene. Those molecules which are having more than 60 forms and structures are called fullerene molecules. Fullerene is not the scientist's name. That name is an architect name. Architect Buckminster Fuller, who is very famous to construct such type of big geodesic structures, football-shaped domes. So the person, Kroto and Smalley, when they have prepared this structure, when they saw, they have felt that it is similar to their friend Buckminster Fullerene's architectures and buildings. So it's the name of the architect they kept for this particular molecule, Buckminster fullerene C60. This is also another electrophic forms of carbon. Mostly these electrophic forms of carbon, the C60 and fullerene molecules, will be used in medicines. So we have learned 3 electric forms of carbon. Can you say? Diamond, graphite, C60. Diamond molecular arrangement, how it looks like? Tetrahedral arrangement. Graphite, hexagonal arrays, forms a layers by layer and makes it smooth. C60, a football shaped structure. Here in diamond you can see that diamond, each carbon combined with 4 carbons. In graphite, what did you see that? Each carbon combined with 3 carbons. In Buckminster fullerene, you can see the 12 pentagon and 20 hexagon rings between the carbon atoms. And diamond is bad conductor of heat and electricity. And graphite is good conductor of electricity. Buckminster fullerene molecules are used in medicine. So, I hope so that you understood what is allotropy. What is allotropy? Existence of same element, 2 or more physical forms, but their chemical properties are same. What are allotrophic forms of carbon? Diamond, graphite, C60. These 3 are called crystalline allotrophic forms of carbon. Okay, Nana. Now we are going to see another thing, versatile nature of carbon. I already said, carbon forms innumerable of compounds. Around 3 million compounds the carbon have prepared. Carbon compounds are there. In toothpaste, carbon is there. In cloth, carbon is there. In food, carbon is there. And scientists are preparing every day nearly 100 to 200 carbon compounds, new compounds. And that list is increasing. If you put all the carbon compounds on one side and remaining all non-carbon compounds on another side, you will see that the list is more. The number of carbon compounds is more than this. Why carbon is forming that many compounds? What made the carbon is so special? Mainly 2 properties. The first property is catenation and second property is tetravalency. We are going to see what is a catenation. The carbon can form chains. Carbon can combine with another carbon, carbon will combine with another carbon, carbon will combine another carbon, and it forms a long chain structure. It can form long chain structure. And second, it can form branch chains also. This carbon can form branches also. And it forms the ring structures also. Carbon can form branch chains, carbon can form long chains, carbon can form ring structures. This phenomenon, ability to form long chains, branched chains, ring structure is called catenation. Carbon has the catenation property. Not only that, carbon can form single bonds, can form double bonds, can form triple bonds. That made the carbon is so unique, and it made the carbon to form innumerable of compounds. And second property we are going to see, tetravalency. Tetra means 4. Carbon has 4 valence electrons. It can form the bonds easily with the other elements. And carbon atom is small. Because of the small size, carbon is forming the strong bonds with the other molecules. Because of its small size. Carbon can form bonds with nitrogen, oxygen, sulfur, hydrogen, halogens, and even with other carbons also, and gives a special properties to those elements. And it forms the very strong bond because the carbon size is very small. Because of that, nucleus, carbon nucleus, can hold the electrons, bonded electrons firmly. The larger atoms cannot form that much of strong bonds. Because carbon has tetravalency and its small size, it is forming the strong bonds. Because of these two properties, which properties? Catenation and tetravalency. What is catenation? Ability to form the long chain, branched chains, ring structures. Tetravalency means 4 valence electrons, and due to its small size, it is forming the strong bonds. The carbon is forming this many compounds. That's why the carbon is so versatile, because of these two properties. Okay, Nana? Now, this carbon compounds will be called with the name as organic chemistry. What is organic? Organic means living things, plants and animals. Why they have kept the name like that? The scientists thought that these compounds can be made only from the living things, and living things only can make this one. And there is a vital force that made these molecules to form. So, and they thought that in laboratory it is impossible to prepare these molecules. That vital force theory made the scientists to keep the name as organic chemistry. They studied like that. But one scientist whose name is Euler, he shattered that particular concept. He prepared from ammonium cyanide in laboratory urea, which is an organic compound in the laboratory. So first organic compound which is prepared in the laboratory is urea. Who prepared it? Euler. Their own words, the scientists have started to prepare so many organic compound molecules or carbon molecules in the laboratory. Now the vital force theory is no longer valid. Okay, except oxides of carbon, carbonates and hydrogen carbonates, except these, the remaining all carbon compounds are learned under the heading of organic chemistry. Nana, I think you all have understood why the name has come as organic chemistry. Because they thought that only living things can form these compounds. That's why they named that organic chemistry. But is that true? Euler shattered that theory and he prepared one synthetic compound, organic compound in the laboratory. From ammonium cyanide he prepared the urea. Thank you. But what we have learned from the beginning, we can recollect. What we learned first, electroforms of carbon. What are electroforms of carbon? Existence of same element in 2 or more forms are called, which are having the different physical properties but same chemical properties. That particular phenomenon we call it as electrophy. What are the electrophy forms of carbon? Diamond, graphite, C60. Why they have different physical properties? Because their bonding structure is different. How they bonded in diamond and graphite in C60? In diamond, each carbon combined with 4 carbons. In graphite, each carbon combined with 3 carbons with 1 double bond. And in C60, 60 carbons forms pentagon and hexagonal rings. There the tetrahedral arrangement, here the hexagonal array arrangement, and here football structure. Diamond is bad conductor of heat and electricity because no electrons are available. Graphite is good conductor of heat and electricity as their bonds are weak. Buckminster fullerene used in medicinal purposes. And second part we have learned what Why carbon is so versatile? It can form this many innumerable compounds. We have learned because of its catenation and tetravalency. What did we learn about catenation? The ability to form long chains, branched chains, and ring structures. And tetravalency means having the 4 valence electrons, it can form the many bonds with nitrogen, oxygen, sulfur, hydrogen, as well as with other carbons also. As carbon is having the small size, it is forming the strong bonds. And also at the last we have seen why the organic chemistry name has come, because they thought that only living organisms can make these molecules, and there is a vital force responsible for the formation of this molecule. But is that true? No. Wohler has synthetically prepared urea in the laboratory from ammonium cyanide. Now, but still we kept the name like that, organic chemistry, except oxides of carbon, carbonates and bicarbonates. Remaining all compounds of carbon we learn under the heading of carbon chemistry or organic chemistry. Thank you very much, Nana. I hope so that you understand my content.